First question. The correct set of quantum numbers n, l, m for the unpaired electron of chlorine atom respectively is. So we know the chlorine atom electronic configuration, or the atomic number first of all is 17. So we can write the noble gas neon, that is 10, then 3s2 and 3p5, this 7. So this is a 17. I can write the box structure, that is this neon with 3s2, 2 electrons, and 3p5, 1, 2, 3, 4 and 5. So for the unpaired electron, so now if I put the orbital's name, so it is 3px, 3py and 3pz. Now we are supposed to, the question asked for the unpaired electron, that means we are talking about this electron, this unpaired electron, we have to write the quantum number. So quantum number n is equals to 3, n is equals to 3 we got. Now L is the magnetic azimuthal quantum number. So here it is there in the p subshell. So we know L is equals to 0 is for S subshell, L is equals to 1 is for p subshell. So here these are the p subshells where the unpaired electron are present. So L value is 1. Now we are supposed to look for M. M is there for the Z, and the Z value, for the M also we have -1, 0 and +1. That means this Px is -1, this 0 and this is for +1. So Pz ke liye the M value is +1. So here also we have 1. And S. So since you can see this is this type of electron. So this have positive half spin and this have negative half spin. So S is +12. So this is a set of particular quantum number. Now question has asked about only n, l and m. So that is 3, 1 and 1. So looking towards the option, we have only one option which says this. That is option C, 3, 1, 1. So correct answer for this question is option C. Looking towards the next question. Which of the following statement is incorrect? First, electronic configuration of chromium is argon 3d5 4s1. Atomic number of chromium is 24. So your electronic configuration of chromium is absolutely correct, and both 3d and 4s orbitals are half filled. This leads to extra stability. So this is correct statement. Next, the magnetic quantum number may have a negative value. Yeah, so when the L value is equals to suppose 1, then M value starts from -1, 0 and +1. So magnetic value may have a negative value. So this statement is also a correct statement. Looking for the option C. In silver atom, 23 electrons have spin of one type and 24 of opposite type. Atomic number Ag, that is silver, is 47. In silver atom, 23 electrons have this because it's 2 electrons in an electron pair have opposite spin, and it has one unpaired electron. Okay, so 23 are pairs. So 23 have one type of spin and 24 have opposite type of spin. So this statement is also a correct statement. Last statement, the oxidation state of nitrogen in HN3 is -3 is given. So this is, let's check for this. So let the oxidation state of this the nitrogen, let X. So hydrogen we know it's +1. Then there are 3 nitrogen which we don't know, it's X, which is equals to 0. So let's take my +1 over here, so it will become -1, and 3 over here in the denominator, so it will become -1/3. So X, that is the oxidation number of nitrogen, is -1/3 and not -3. So this is an incorrect statement. Option D. Looking to the next question. The total number of electrons present in all the s orbitals of all the p orbitals and all the d orbitals of cesium ion are respectively. So first of all, we need to know that cesium, atomic number 35, have electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, then 5s2, 5p6, and then 6s1. Now if we talk about cesium ion, so it is Cs plus 1. So this one electron will be removed and rest all will be the configuration for cesium ion. Let's count the total number of s orbital electrons, p electrons and d electrons. So this 2 plus 2, 4, 6, 7, 8 and 9, 10. So s orbital electrons we have 10. Look for p. This 6, this 6, 12, this 6, 18 and this 6, 24. So p orbital electron is 24. Then look for d. This 10, this 10, that becomes 20. So d orbital electrons are 20. So we need to have 10, 24 and 20 and it's there only in option B. Therefore the correct answer for this question is option B. Looking towards the next question. The quantum number plus half and minus half for the electron spin represents. So just like Earth rotates around its axis, the electron spins about its axis either clockwise or anti-clockwise manner. The two types of rotation are plus half and minus half. These two quantum mechanical spin states which have no classical analog, hence the correct answer is option D, which says both A and C, that is rotation of the electron in clockwise and anti-clockwise direction respectively, and C is two quantum mechanical spin states which have no classical analog. So correct answer is option D. Looking towards the last question. The de Broglie wavelength of a tennis ball of mass given, that is 60 gram, moving with the velocity of 10 meters per second approximately. So we have de Broglie formula, lambda is equals to h upon mv. We are supposed to find out lambda. Let's put the values. H is constant, that is 6.63 into 10 raised to minus 34. The whole upon m is 60 gram. So we are supposed to put in kg, that is 60 into 10 raised to minus 3. And this velocity 10 meter per second. So this will become 10 raised to minus 33 meter. So the correct answer for this question is option A, 10 raised to minus 33.